Welcome to Study Loop.
In part A, we are asked to derive a relation between a speed factor beta, a recessional speed factor precisely, to the redshift z. We can write the relativistic Doppler effect formula is L naught initial wavelength to the wavelength times 1 minus beta square over the same thing differ by this is not a square, sorry about that. So it's not square, so only 1 minus beta and then 1 plus beta here. So this is equal to lambda naught plus delta lambda. So lambda is equal to the lambda naught plus delta, and this is equal to times 1 minus beta over the same thing but differ by sign, 1 plus beta. So here we will divide lambda naught here on both sides. So here lambda naught, they will cancel out each other, and then we are left with 1, and we can write z is equal to delta lambda to the lambda naught. If we substitute this value and do the cancellation, then here we get 1 plus z times the 1 minus beta over 1 plus beta. Here we will solve for a beta. So when we solve for a beta in terms of z, then the relationship between a z and a beta we get here is a z square plus 2z over z square plus 2z plus z. So this is a relationship between beta and a redshift. In part B, we are asked to find what will be the beta value of a beta if we have a redshift of which is given 4.43 redshift. The straightforward answer will be just plug this value here, everywhere where you see the z, and solve for beta. So the beta value here we get here is 0.934. So the beta is our recessional speed factor, 0.934. Okay. So from here, then we can find the distance. We can find the distance using the Hubble law. So this is part C. So the distance, let's say capital R, is equal to the velocity over the Hubble constant. Velocity we can write using a beta, that is simply a beta times c over the Hubble constant h. Now what we need to do is plug these values. We already have a beta 0.934. We know the speed of light, so the Hubble constant we have here is 0.0218. And once we substitute this value here and multiply with c, then the distance we get here is 1.28 times 10 to the power 10 years. 10 to the power 10 years. Light years, actually. End of the problem. Thank you for watching.